Oh, hello everybody. My name's Dave, and my PhD, which I'm taking at the moment at Oxford, is concerned very much about the evolution and phylogeny of the early reptiles. Now, before I kick off and the really interesting stuff, I'm going to put some thanks in. I've been rummaging around in the collections of many a beautiful museum in the past year, and I particularly want to thank the guys at Sam Noble Museum in Oklahoma for allowing me to take a close look at these two beautiful specimens of OROVENATOR mayorum. The one on the top there, 74606, is the best preserved of the two specimens. We believe it to be a subadult because it's some 35% smaller than similar elements within 607. They're both quite small skulls, no more than about 2.5 centimeters in length. And we had them CT scanned at University of Texas, Austin, and we got it down to a resolution of around 18 microns. When we managed to take a look at the scan, we were really quite taken aback by the fantastic contrast we managed to get between the matrix and the bones themselves. Now, OROVENATOR was first described by Robert Rice and colleagues in 2011. Robert quite correctly assumed that this was a diapsid, even though the post-orbital and the squamosal is absent. And when he carried out a phylogenetic examination of the material, he used a matrix which was pretty much heavily loaded with diapsida, because he clearly wanted to find out exactly where this fell within the diapsida. And what he found was that it was very closely related to the earliest diapsid, Petrolacosaurus from the late Pennsylvanian, and that OROVENATOR was the first of the neodiapsid line, which, as we know, eventually led to all extant birds and reptiles. Now, in my preliminary investigation into this particular specimen, I was quite taken aback by the list of similarities which I found in the skull with another group of reptiles, which were the Palaeontology, which Neil has just explained, so I haven't got to go through it too much with you, and in particular, the Varanopids. Now, I shouldn't be surprised, perhaps, that there are similarities between diapsids and Varanopids, because 4 of these taxa spent at least 10 years apiece as diapsids before they were changed into and shown the bright sunlit uplands of Synapsida by Robert Rice and colleagues. In fact, conversely, if we look at Petrolacosaurus, it was originally ascribed to the Synapsida and then taken into the diapsida in 1977 by Rob Rice. So much for the setting of where we find OROVENATOR, which by the way, which I didn't mention, is from the early Permian of Oklahoma. Let's take a look at some of the data we actually found from the scan. Here are the premaxillae. They've been put together artificially. They were actually quite separated. What I'm quite interested in here is taking a look at this subnarial bar, which is very rounded. Normally you would find a very specific sharp difference between the lateral side of the subnarial bar and the ventral side of the external nares. This is very rounded, and you'll find in most phylogenies that this particular morphology is a synapomorphy of Varanopids. You also might notice this rather deep notch, this medial process, which received the anterior process of the Boma. Here we'll take a quick look at that process there. You see that looking at it from a ventral point of view. You see that on the medial side, the process is quite large, about 2 or 3 times larger than the small lateral process, and the vomarine process of the premaxilla fits nicely into a notch between the two. Now, we also find this very specific morphology in Mesanosaurus, which is a Varanopid. We find it in the basal Varanopid Archaeovenator, and I myself have noticed that it belongs also in the diapsid Petrolacosaurus. Now, for those of you who get excited about septa maxillae, and there must be some of you out here, this is going to be quite interesting, I hope. It's very rare to find an intact septa maxilla actually within an early diapsid, or even an early synapsid for that matter. But here we have an intact septa maxilla, which, as you can see, is extraordinarily small. It's just over 1 millimeter in width. You can see here the posterior view, we're looking straight down the septomaxillary canal. We can see a very interesting dorsal process. And what I'm going to try and do, somehow or other, maybe not. As you said, Neil, there's always something that fails on this. I need to get it there.
To play it.
Yeah, just needs to go there. Okay, so yeah, here we go. Thanks very much. And here we see us moving around to the lateral side of this. And right there, I'll stop it. So laterally, when you have looked into the external nares, you would have seen this very large rectangular plate sticking in the external nares, which would have almost subdivided the anterior and posterior parts of the nares. We'll move further round, where we'll see the anterior exit of the septomaxillary canal, and this very flat ventromedial shelf, which we think would have met its partner along the midpoint of the snout of OROVENATOR. Now that would have sat, as we said, inside the internal nares like this, and the internal nares itself is going to be quite elongate and would have had a small posterior dorsal extension there at the back, squeezed between the nares and the maxilla. Now, this posterior dorsal extension is another synapomorphy of the Varanopids. As we can see here in Archivenator from Rice and Dilks 2003, there is this extension, posterior dorsal extension of the external nares, as well as this partitioning of the external nares by this flat rectangular septomaxilla. Now, we managed to reconstruct the whole of the palate from the subadult specimen. And what I'm quite interested in here is this very elongate and anterior-posteriorly elongate internal nares, and in particular, this deep excavation of the anterior margin of the palatine. Now, we find this deep excavation also in Varanopids. We do not find it in any other synapsid that I've been able to see so far. The culture film process of the basoparis sphenoid is dentitious, which again we find in new reptiles, we find it in early diapsids, we find it in Varanopids. I have to admit we also find it in caseosaur pelycosaurs, but it's definitely in Varanopids as well. Now, one of the main things which separates a Varanopid, or any synapsid for that matter, from a diapsid, apart from the temporal fenestration, is the suborbital fenestra. And we have to say, since that this is a diapsid we're dealing with, it does have a suborbital fenestra, but it is very narrow mediolaterally. Anteriorly, as you can see on the actual reconstruction on the left, it's virtually closed. Now the question is this a suborbital fenestra which is on the way to closing, or because it's a lot narrower than earlier material that we find in Petrolacosaurus? We have a very well-preserved parabasi sphenoid. Here I particularly want to show you the pituitary fossa, which you can see, which is just anterior. We're looking at the dorsal view. And right now you can see a couple of small foramen, which just come from the base of the pituitary fossa, and from them we see the entry of the internal carotid arteries into the brain case. Now if I get rid of that, we're going to try and trace these carotid arteries through the brain case. We're looking at the dorsal side. We can see them just protruding through there, the pituitary fossa. We're going to turn this around to take a look at the ventral surface of the parasphenoid. And right there, we'll stop it. We'll see that the carotid artery comes from the lateral side of the brain case. It dives into a deep sulcus below the parasphenoid process, parapterygoid process, and then dives into a foramen just anterior to that process. Now, this isn't an unusual morphology for diapsid reptiles. In fact, you find it where we do have good brain cases, such as in Youngina and in Prolacerta. We do find this very similar morphology. What you do not find in most pelycosaurs is a similar morphology. The entrance of the ITCs are on the ventral plate of the parasphenoid and between the two basiparasitoid processes. In Varanopids, it is not like this. We're not quite sure what it's like. There's some contention, but it certainly does not enter the brain case on the ventral plate. We have a nice posterior mandible here of Orovenator. A couple of things I want to point out to here are the dorsomedial shelf of the Sarangula. This is quite specific. It overhangs the adductor fossa on the medial side of the mandible, and it sends forward a very slim splint-like anterodorsal exposure of the Sarangula, which separates the coronoid from the dentary. Now, this morphology has been seen in 4 other Varanopid pelycosaurs, and we can add a 5th to that because I was lucky enough to get a scan of Mictorosaurus from the Field Museum in Chicago, and as you can see, the morphology is almost exactly similar. There is a dorsomedial shelf, and there is a small splint-like interjection of the Sarangula between the posterior dentary and the coronoid. By using both of the specimens of Orovenator, we've been able to reconstruct the skull. So looking at this from an anterior position, we see that it's actually very wide across the anterior point of the orbit. And this is because the preorbital bone has a very flat dorsal exposure. And this exposure, which we see on the preorbital, is very similar to what we see in Varanopids. We'll move around, and just as an incident, we do have a series of in situ sclerotic plates, which we've expanded a little, and we'll be doing some more work on that, I hope, in the coming few months. You notice we are missing the whole of the occipital region is missing, and unfortunately, much of the posterior part of the temporal area. Now, this is fine. We've got some nice new data. What do we do with it? Well, ideally, we'd like to stick it into a nice phylogeny and see how it works. But as I said earlier on, the phylogeny which was accompanied the paper on Orovenator was really skewed towards finding its position in the Diapsida. But never mind about that, because once more we have Rob Rice to the rescue, because the year before he had produced a paper on Apsisaurus, in which he decided that Apsisaurus wasn't a diapsid, it was in fact a Varanopid, and he used about 113 characters for this and 27 taxa and using Palate. Now, I'm using TNT, so I've used more or less the same data which Rob used in this particular study, but I did make one change. That was to Misenosaurus, where Robert scored it with 2 coronoids, when in fact it only has 1. So I made that one change to character number 60. And the results which I got were exactly the same, more or less, apart from the small polytomy that Rob had in his original paper. That's to say, we have the Varanopids situated very nicely within the synapsida. We have the, just 2 families represented there, the casiosaurs and the orphiacodonts, but they're still sitting very nicely within the synapsida. And we have all of the diapsids sitting within the Eureptilia, as we all expect should be. So we take the new data, and we score up those 113 characters, and we result with this. The synapsida has now been reduced to just 2 families. Whilst we still have a monophyletic Varanopidae, they nest within the Diapsida, with Petrolacosaurus and Orovenator basal to them. So a skull with 2 fenestrae basal to a skull of a family with 1 fenestra. So very briefly, what are my conclusions from this? Certainly that the micro-CT scan of the 2 specimens from Oklahoma has revealed incredibly new details, which we can work on for the anatomy of the skull of Orovenator. And the inclusion of these data into a matrix previously used to differentiate between Varanopids and Diapsids results in a monophyletic Varanopidae within Diapsida. And we must also assume that temporal fenestration may be more variable within these lineages than we currently believe. However, and here's my caveat, 113 characters and 27 taxa, we would need to be a little bit more robust than this if we were going to push this hypothesis any further. It's something which myself and my supervisor are currently working on. However, I do believe that we find sufficient evidence to suggest that the position of Varanopids in early amniote phylogeny must remain open to further debate and discussion. And at that, I'll say thank you for listening, and I'm going to go and hide under a stone. Thank you very much.